actually will. Recording. I'll actually try to record every class so that if you... Sorry about this. I'm a little discombobulated today. I'll actually try to record every class so that if you miss class, there'll be a video recording for you. All right, so let's take a look at the overview on page 3. Today, we'll do two distributions, the binomial distribution and the normal distribution. Normal distribution is just the standard bell curve. That is everything in this statistics class and pretty much everything in statistics. The normal distribution allows us to make assumptions about so many different things. What's the average income in a town? What is the average error rate? And we'll talk about that, and that will just provide the foundation for the stuff we'll talk about later on in the course. So we'll warm up with the binomial, and we'll see how that shows us the normal distribution, and that will be our base for today. Next week, we'll talk about determining a sample mean. So a mean is just an average. So what's the average amount of money that teenagers spend online? All right, we can't ask every single teenager, but we can take a sample, and we can determine how confident we are about that sample, and we can determine how big the market might be because of that data. We might also ask a question such as, what is the average income in this town? And when I can't ask everyone in the town, we can take a sample, and we can make business decisions based on that. So next week we'll talk about sampling, developing those sample means. Class 3, we'll talk about proportions. Proportions are just percentages. A mean would be the average income in a town. A proportion would be between 0 and 100%, such as how likely are you to vote for Donald Trump? How likely are you to support this proposal? It would be between 0 and 100%. And a lot of things are the same when we calculate a mean and calculate a proportion, but there are just some differences. All right. Class 4, hypothesis testing. Has anyone heard of hypothesis testing before? All right, so you have a hypothesis, something you assume to be true, and then you will look for evidence to the contrary or evidence to support that conclusion. And it's just a scientific way of solving a problem, scientific way of asking a question. So suppose I'm going to assume that there are no errors, or that the error rate in this production process is less than 5%. All right, well, on the whole, it might be less than 5%, but maybe one day it might be 6% or 12% or 4%. It might fluctuate around there. So I'm going to set up some sort of hypothesis test to determine how high that error rate might have to be before I conclude that I'm positive that it has a higher error rate than 5%. So, just a scientific way to make those sorts of decisions, hypothesis testing. Class 5, we will take what we know about proportions, means, differences between means, and we will combine that with hypothesis testing. Now, there's been a slight change I mentioned on this syllabus from the one I sent you on Blackboard a week or so ago, and that is we do not have class on January 2nd. So I tried to think about, hey, come on, have a seat. There's two handouts right in the back. You can grab the syllabus and the class slides. I tried to think about how I wanted to present this material. I definitely considered just skipping this whole section of material, class 5, and maybe as you're looking at it right now, you may have thought, well, it would have been great if you just skipped that section of material. But the truth is, this material is just a combination of things. It's a combination of hypothesis testing and a combination of what we do in class 3. So it's honestly a good chance just to reflect on what we already know about those two things. It's not a lot more work, It's just a good summation. So for that reason, I decided to continue to give you that material. So I have a video which you can watch, which will demonstrate that material. And that's what we're going to do for class 5. So you'll have like 3 weeks to do that while you're watching the video. Maybe you'll be like, wish I didn't even have to watch this video. But once you get done, you'll say, all right, I feel like this was a good decision, and now I'm more confident about those principles with hypothesis testing. Because hypothesis testing is not too difficult, but I just have had students that get frustrated because they just haven't had enough time or enough exposure with it. So I think doing it this way is going to be best for you. All right, class 6, regression analysis. Who knows what regression analysis is? No? I not only do not know, but there's a frown with regression analysis. All right, regression analysis is determining a correlation between 2 variables, such as the amount of time someone spends online and the amount of money someone spends online. So suppose one person spends 2 hours a week online, another person spends 50 hours a week online. Who do you think spends more money online? Yeah, you might, common sense, intuitively, you might say the person who spends 50 hours a week online is going to spend more money. So let's look at a sample of, say, 10, 30, 50 people. Let's ask them how much time they spend online. Let's ask them how much money they spend online. And let's draw a line. All right, so time spent online here, money spent online here. Let's plot all the data. All right, it has an upward sloping line. All right, there's a mathematical calculation we can use. If you tell me how much time you spend online, I can make an estimate of how much money you spend online. So I might target certain people to buy my products based on how much time they spend online. I might make certain business decisions with that information. So the predictive ability to determine how much money someone's going to spend online based on how much time. And of course, this could be anything. This could be the amount of advertising a company spends versus how much revenue they generate. Is there a correlation there? Like if there's no correlation there, like those 2 things are not related, then why would a company invest in advertising? You might crunch the numbers and say it doesn't matter how much you spend on advertising, you're still going to sell the same number of products. Or you might tell them very specifically, this is how much each dollar of advertising can bring in revenue. Okay, so that is regression. And the next class we'll look at multiple regression, which is multiple variables. So I still want to know how much money you spend online, but instead of just one variable, I'm going to look at 2 or 3 or 6. I want to know how much time you spend online. I want to know whether or not you have a job. I want to know how spontaneous you are with your spending habits. And I want to know your income. All right, if I have those 4 variables, maybe I'm going to get a different line. Maybe I'm going to get a more accurate line. Maybe I'm going to get a line that has a smaller confidence interval, where I can make more precise predictions. So we'll just think about how to do that with multiple regression. All right. Class 8, chi-squared tests. Chi-squared tests are an interesting culmination of what we'll do in this class. It's a slightly different way of looking at a lot of things. We'll look at test for independence. We will look at goodness of fit. So a test for independent would be a similar question. A test for independence would be a similar question we just asked. There's a syllabus and class slides there on the back if you need it. A test for independence would be a similar question we just asked with the regression. All right, how much time you spend online, is that related to how much money you spend online? So we could draw a regression line with that. We could also do a chi-squared test with that. We could also look at an independence test for something like If you're male or female, does that determine your likelihood to support a certain company change? All right, you might say, well, a larger percentage of men support this change, and a smaller percentage of women support this change. So gender and your support of this change are not independent. They're related. And a chi-squared is just a different way to do that. All right. Any questions so far? Are you excited? Intrigued? All right, have I wooed you in a little bit? All right, statistics has taken a little bit of a beating in the last month or so with the election results. We'll look a little bit about that. A lot of people were disappointed that the statisticians supposedly got it wrong. I really don't think the statisticians got it too wrong. I think the people who actually took the statisticians' numbers and tried to make more precise predictions are the ones who got it wrong. The statisticians just took the polls. The people I think who really got it wrong are the ones who said, based on all this data, there's a 90% chance that Hillary Clinton will win. Well, they were considering more than just the statisticians' numbers of proportions and means, but we'll talk a little bit about that as we get to it. I still think there's a lot of value in statistics, and I think there's a lot of work that you'll be doing as business people to support your business operations, and your ability to just understand the basics of this material will enhance your value in your company and whatever business you're working in. All right, so let's think a little bit about how this is going to work logistically. So, how do I want to do this? Let's go back to class 1. So you can see we've got the topic on class 1, and then we've got assignments. So these are assignments associated with class 1 material. I've got a couple sections I suggest you read. I've got chapter exercises that I suggest you do. And I've got Excel exercises that I would ask you to do for homework. So the chapter exercises, that is preparation for the quiz. So you have one quiz each week based on the previous week's material. So, and that quiz will be taken on Blackboard, and it will be due before the next class. So the material we cover tonight, binomial distribution, normal distribution. You'll take a look at chapter 2 exercises, 1, 2, chapter 4 exercises, 56, 58, chapter 5, so on and so forth. You'll work through those, practice those. Then you'll be feeling good about the material, feeling like you can answer those questions. Then you'll log on to Blackboard, and I'll pull up Blackboard in a minute. And you'll click on Quiz 1, Class 1 Quiz, and there will be a few questions, very similar to the chapter exercises. And you will answer those and get a grade each class. Does that make sense? Have you all taken quizzes on Blackboard before?
Are they timed?
They are timed. I think the first 4 or 5 quizzes are 90 minutes time limit, and the ones after that are 120 minutes time limit. The ones after that, sometimes you'll have to use Excel and some other complicating factors, so I give you a little extra time. It's not like the ones in the second half of the class are that much more difficult though. So, yeah.
So what is homework? Is homework just the quiz, or is homework like complete chapter? Like you have Excel exercises and then work on chapters. So which one's homework?
Yes. Okay. So the work chapter exercises, that is homework, and there's homework I would suggest you do to prepare for the quiz. Where it says complete chapter 2 Excel exercises, that's actual homework that you will turn in. So, you will have 2 things due next week for tonight's, based on the material you learned tonight. One will be the class 1 quiz, and you can look in the class 2 December 5th. See, it says bolded class 1 quiz complete via Blackboard prior to class, and submit chapter 2, 5, 6 Excel exercises via Blackboard. So, you'll for chapter 2 exercises, you'll look at the back of chapter 2, and you'll look at Excel exercise 1, 2, and 3, and there will be instructions there. It will say, here's 6 numbers, find the population mean, find the standard deviation. Do whatever it asks you to do in those exercises. And you will turn that in prior to class next week. Yes?
Are these in the textbook?
Yes. Yes. Does everyone have the textbook?
It says right here.
Yeah, that looks right. 2014? Yeah, that's probably
Okay.
right. Yeah, I mean, if you need an extra week to get the textbook, that's okay.
Do we need the textbooks to do the homework?
Yeah, because the homework, the practice problems will be from the textbook, and the Excel exercises will also be from the textbook. In general, I like to ask that you have the quizzes done before coming to class the next week. I do ask that you have the Excel exercises done at the same time, but that's really not a big deal. If you need extra time to do the Excel exercises, that's fine. I've had students turn in Excel exercises a week or two late. I would recommend you do the Excel exercises just so you can reinforce the material. And also you don't want a bunch of Excel exercises to do as you're trying to cram for the next class. But I do ask that you get the quizzes done on time each week because we will go over the answers in the next class. Like the quiz questions for class 1 quiz, we'll go over those next week. So you want to have those done. But of course, if you need extra time for Excel, that's fine. Does that make sense? All right, for the Excel, I do have some Excel data sheets. Let me actually pull up Blackboard right now, and I will go over some of this, make sure you're, let's see. All right, so under course material, that's where everything is. All right, so we've got the class quizzes.
How did we get to that part right there? I'm sorry.
Let's see, so you'll go, you'll log into Blackboard somehow. Let me see, it might look something like this. I don't know, actually.
You gotta copy and paste the link.
You can go directly
On
to
the
the
front.
mercy.edu and then click on Blackboard, and then you log in.
Okay, all right, so mercy.edu, click on Blackboard, log in with your Mercy credentials. Does that make sense? All right, and you should have maybe 2 or 3 classes, depending on how many you're taking, or 1 class, at least this class. And what happened? Where did I go? I'm looking for. All right, and everything in this class will be under course material. So for the class quizzes, all right, once you do the homework, you're feeling good about this, maybe you start, maybe even finish the Excel exercises, just reinforce the material a little bit that way. And you can use Excel on the quiz. You can use, the quizzes are all open book, open note. So whatever helps you get the right answers on the homework problems, the ones you work out in the textbook, those same techniques will help you get the right answers on the quizzes. Yes?
Once we open the quiz, do we need to do it straight through?
Yes.
Okay.
So you'll click on quiz, you click on class 1 quiz. All right, class 1 quiz, this is open book, open note, must be completed individually, so you can't share answers with other people, can't text each other answers, please don't do that. It has a time limit of 1 hour and 30 minutes. This will save and submit automatically once time expires. All right, then you'll click on begin and give you a little preview here. All right, write down this as fast as you can. All right, so there are 6 questions. Oh, there's an extra credit. There's an extra credit question on this first one. Keep this page. Yeah, so there's 5 questions and 1 extra credit question on the first quiz. So that's a quiz. For Excel. I've got these Excel worksheets. So for chapter 2, 5, and 6, you will just click on it and you can open it.
Or you just do it.
And we've got everything laid out here for you. So I think for chapter 2, you're required to do 1, 2, and 3. So when you're doing question 1, it will, I think it says, it asks you for the mean of all this data. So you'll click right in the orange. And I think I've been pretty good about putting the orange or the peach or whatever that is. These are the things that you're required to fill in. So there's a syllabus and class slides right behind you.
I want to make sure I'm in the right class. 110.
601? Yeah.
Okay.
601?
Yeah.
Business, quantitative,
Yeah.
stats. This again, we went over this earlier. Quantitative methods in business research.
Yes.
All right, perfect. All right, so the mean, so if you want the mean, are you all familiar with Excel? Used Excel a little bit? Or if you haven't, you might do something, it'll explain all this in the textbook. It'll literally walk you through what to do to calculate the mean in Excel. And it might be something like this, equals,
Enable editing at top.
enable editing. Oh, thank you so much.
You click
All right, equals average, this one, this one, equals average, open parentheses, go over here, select all these, I want the average of those, boom, mean is 35. Median, down here, I don't even remember what this one is.
Median.
Equals median, equals median. Yes, very good. Median, open parentheses, this, boom, done. All right, so you do that for all of these, chapter 5, binomial probabilities, etc., and so forth. Save it when you're done. And then you will go back to course material, class assignments, click on class assignments, and this one, and you will upload and submit somehow. I don't know if your screen will look exactly like this. Normally, people just tinker around with it a little bit and they figure it out. Maybe there's a problem the first time, work it out if we have to. But that's that. Alright, so that's quizzes, class assignments, class slides. Alright, so I will give you class slides, but I will post these.
Excuse me, I'm sorry. Is
Yeah.
it possible that I don't have this because I just registered today? Is that, because I'm clicking on here, it's not coming out.
Let's see,
The course
so.
material and all that. If I click on, I just registered
Oh,
today.
that's 535.
Oh, I'm in the wrong class.
Yeah,
Okay.
you're in the, who's your 535 teacher?
Okay.
Zarelli, yeah, he doesn't do anything on Blackboard.
Okay.
So yeah, just go back to like the home screen, I think on the upper right.
Right here, this is the one, right? This is-
Bingo.
Okay, thank you.
Yes.
Okay.
All right. Yeah, class slides. So I think it would be much to your benefit if you took a look at these class slides prior to coming to class. It will give you a good overview of what you're going to learn. I'll actually often reference certain examples that we're going to look at in the textbook. It's really a good way to skim through the chapter. And then maybe after you do that, you can look at the chapter and fill in a little bit of the information. And maybe even take an attempt at some of those homework problems. So I'm talking about before you even come to class. So for next week, you might look at the slides, read through those, try to think about what we're going to talk about in terms of sampling, confidence intervals, margin of error. You might take a crack at working some of the exercises. Maybe even take a crack at working some of the Excel exercises, just an hour or so, just to get yourself used to this material. I think that's the best way to do it. The more you know about this material coming in, I think the more you'll be able to absorb it when we go over it during class. That was my strategy in business school. I would come into earlier sections and just try to swipe some of the slides, because we didn't have stuff online when I went to business school so much. But I felt like those slides told me where the professor was going to gear the material, gave me the information I needed to be better positioned to absorb it. All right, so that's class slides. I'll have those up probably by Friday at the latest. All right, and Excel exercise data. We already went over that. Class video recordings. So I should, hopefully, unless something bad happens, have each of these classes recorded. So if you want to review some of the material, or if you missed class, you can click on class video recordings, and this will be a link which will take you right to YouTube. All right, any questions on any of that? All right, so a lot of things you have, a lot of materials you have to learn this material, and I would really recommend you use all of it. This class is often challenging for most MBA students, and I think it's going to take maybe 8 to 10 hours of outside preparation to really get a handle on the material. When we go over the material in class, normally I get good feedback that it's understandable, that you're able to understand the material as I teach it. The problem comes when we have the next class and it's a concept added onto that and you haven't really reinforced that. Because a lot of this stuff is not too complicated, but it's just simple concept built on top of simple concept, simple concept, which can be confusing if you don't stay on top of it. So I, again, recommend before class, you take a look at the slides, try to work a couple of the problems. After class, you really do those homework problems thoroughly. Do the Excel problems to get fluent with that material. And that should put you in good shape for the quiz. And when you take the quiz, after you take the quiz, you should be able to see all the answers. So after you submit the quiz, it'll show you all the answers, and you can actually look back at all the answers and see whether you got it right or wrong. And I'd recommend that you thoroughly look at that as well. Make sure you're comfortable and confident with that material before we move on to the next thing. If you're shaky on the first class, you're going to be even more shaky on the second class, and so on and so forth. Let me show you, I forgot that one thing. I'll show you about looking at answers to quizzes. So you can go to My Grades, all right, and it should show you all the stuff in the class. So you have class 1 quiz, and Excel exercises, and all right, so it should have a score here, right here, and I hope you can see that. It should have a score here for the score you got on that quiz. If I haven't graded it yet, it's going to have one of these. In either case, you can still see the answers to the quiz. You can either click on the score you got, or you can click right on the needs grading thing. I hope this works. No, it's not working. It's not working. Oh, sorry. All right, so first you click on class 1 quiz, then you click on either this bubble or the score that you got. And I'm not going to click on it now because it's going to show you all the answers. All right. Yeah. All right, any questions?
So we should just read the textbook, practice the exercises in there, read the slides, and then go to the quizzes, right? Would we?
Yes,
Okay.
yes. I've heard students say that the quizzes are easy compared to the homework.
The homework is in the textbook, right? The questions that are.
Exactly.
Okay.
exactly.
Does the textbook have like the answers to the questions?
Yes, for almost all of the homework questions I've suggested you do to prepare for the quizzes, the answers are in the back of the book. I think the even answers are in the back of the book, so you should always have the answers to make sure you're on the right track. Alright, let me go through the syllabus and make sure I didn't miss anything. I think I went through pretty much everything. My information is on the top. Email, phone number, if you need to contact me. I have an office just down the hall. If you want to ask some questions, we can set up a time to send me an email. It's generally the best way. You can send me an email on this email, the zwilliams1@mercy.edu. You can also send me an email via Blackboard. I try to keep up on both. Sometimes Blackboard slips through the cracks. So if you want to get a hold of me right away, I would suggest the mercy.edu email. Okay. Attendance policy, you actually don't need to come to class. I hope I can make it exciting for you. I hope you will get something out of the classes that I teach, but you could always just watch the videos if you if you get the material that way. That is acceptable. But I would recommend highly that you come to class, but you're not required to. Plagiarism and cheating policy. The only thing is with all the online quizzes, I of course ask that you don't share answers. That is important. There are a couple of quizzes where I've calibrated some different types of quizzes, so some students will be taking different quizzes just to keep everyone honest. And for the final, I don't say this to scare anyone, I just honestly say this to impress you, to show you how much work I've done preparing this final. That I actually have 20 different versions of the final. It's a major pain to figure out how to get all these versions of the final to begin with. And it was even more of a pain to put all those versions of the final on Blackboard and assign each one of you a different version. So, for some of the quizzes, I will go to that level, and for the final, I will go to that level. So, please don't share answers with each other. You might get away with it, but you might not, so. Plus, you're losing out on developing and learning the material yourself if you share answers with others. Okay, so that's plagiarism and cheating. Textbook. I also recommend you have a calculator so you can do the homework and so you can answer questions on the quizzes, and we'll do problems in class sometimes. You could also use Excel if you feel fluent with that. You could use Excel while we're in class. You could use Excel in the homework and the quizzes. That's acceptable as well. Alright, quizzes and exam, 8 weekly quizzes, 1 final exam, and the final exam will be what would have been our week 10. So instead of coming to class on week 10, you will log into Blackboard and take the final, which will be a culmination of everything. And the final will be very similar to all the quizzes. Will be problems that I test you on in the quizzes, will be the exact same thing I test you on during the final.
It will be?
Yes, exact same content. And the problems will be worded in a very similar fashion as well. For some of them, I just put in different numbers. For some of them, I changed the wording around a little bit. So, yeah, they're all steps in learning this material. Understand the intuition in class, practice with the homework problems, then you should be ready for the quizzes. If you do well on the quizzes, or if you don't do so well on some questions on the quiz, make sure you're confident on that and you'll do well on the exam. And we'll of course talk more about the exam as we get there. Alright, and then you've got the outline, you've got assignments for each class on page 3 and page 4. Of course, we have winter break on, I guess, December 19 plus 7, December 26th, the day after Christmas, we won't come to class. Similarly, July 2nd, you will not come to class. And, of course, we have MLK Day, July 16th, January 16th, sorry. July, sorry.
please.
Yes, sure.
Each one of these assignments that's written out on page 3 is the same thing that's inside of the Blackboard?
Yes,
This is.
yes,
Thank you, I didn't know.
you bet.
Right.
So, the question, yeah, so the assignments are in bold. So the work chapter exercises, that is homework. It's not homework that you'll have to turn in, so, you know, I'd recommend you do it. You're not graded on it.
Are we talking about page 3?
Yeah, on page 3. So work chapter exercises, read sections, that's stuff to prepare for class. If you look on class 2, you'll see 2 things in bold. Those are things that you need to turn in. One is the class 1 quiz, and the other is chapter 2, 5, 6 Excel exercises. And those are all on Blackboard.
And that's all due December 5th?
Yes, both those things are due December 5th prior to class. Make the quiz a priority. Excel, if you need a little extra time, that's not a problem. Question?
The weeks we don't have class, is anything due?
No.
Just bring it the following week?
Yep.
Okay.
Although for the December 19th hypothesis testing, I'd recommend you not wait 3 weeks to do that. Even though technically nothing is due until January 9th. You might want to get that all out of the way so you can enjoy your Christmas. Or enjoy your holiday, excuse me. All right. We've got the grading policy on page 5, and we've just got a summary of assignments and point value. Excel exercises are worth 5 points. Each class quiz is worth 5 points. Total of 40 points for all the quizzes, 40 points for all the Excel exercises, and the final exam is worth 40 points. So 1/3 of the grades are quizzes, 1/3 of the grades are Excel, 1/3 of the grades are the final. The Excel, you should all get 40 out of 40. If you make a good effort, you get 5 out of 5. So that should be 100% for you. The quizzes, maybe you'll stumble a little bit because it's the first time you're doing material under pressure, but you'll see where you were weak, you can brush up on those. And like I mentioned, the exam is very similar to the quiz, so you should have a good chance to do well on that. The final, don't get me wrong, the final can be hard, but it is because you're doing all this all at once, and there's the pressure of like a 3-hour exam. But still, it is all the same stuff, very much exactly the same as you'll see on the quizzes. All right, any questions on any of that? All right, so let's go ahead and do the material for tonight. Did I see any of you in Turbo recently? I saw a few of you. Yes. Good. So if I saw you in Turbo, this stuff we're gonna do tonight should look familiar. If I didn't see you in Turbo, then you had 507. Right? So you should hopefully be feeling good about statistics a little bit in general. And if anyone feels that I'm going through this material too fast, slow me down, and we'll make it happen. We'll make it work. All right. So let's start. All right, so the 2 key things we're going to talk about tonight, the binomial distribution, which will be a warm-up, or the normal distribution. Cool thing about the binomial distribution is we'll actually do the calculations. I'll show you how to do those calculations, you'll do them, and you're like, wow, I just created the normal distribution. And then we'll talk about what that means and what we can assume because of the normal distribution. All right, so to lead up to the binomial probability distribution, I need to teach you a couple things. One, combinations, which is just a counting mechanism. How do you count how many combinations of a certain number of items we could have? And I'll also need to teach you just a couple things about probability. And that's going to give us what we need for the binomial. And then, as I mentioned, we'll say, wow, we just did the calculations to the binomial distribution, and that shows us a great example of a normal distribution. Normal distribution, the classic bell curve. Once we have the classic bell curve, we can evaluate it with measures of central tendency, which are the mean, the medium, and mode. Hopefully you've heard of those before. If you haven't, we'll just go over them and get you those definitions. And measures of dispersion, which means how wide this distribution is, how wide and short it is, or how skinny and tall this bell is, just the shape of the bell distribution. And we'll talk about the assumptions that we can make for a normal distribution. And one of those is we can give each point of data a z-score. And that tells us great things about commonalities. Commonalities between two completely different things that both happen to be normally distributed. Tells us the percent likelihood of certain things to happen, bottom line. All right, so we'll start with binomial distribution. Let me teach you combinations, let me teach you some things about the multiplication rule of probability, and we'll be all set with that. All right, so combinations. Let's take a look here. So, suppose I'm counting combinations. I want to know an answer to this first question. Suppose I have a group of 4 people, Ann, Ward, Jin, and Al. How many different teams of 2 could I have? Anyone want to take a guess? All right.
Six.
Is it like 4 combination 2, or is it 2 combination 4?
Yes, it is. You're right. All right, it's 4 combination. Let's see backwards here. 4 combination 2. All right, what's your name?
Danielle.
Danielle is ahead of us. Don't worry if you don't know how to do this. We'll learn that in a minute. So actually, let me just erase that because I don't want to distract anyone. So let's just think what the answer is. So we could have a team of Ann and Ward. That's 1. We could have a team of Ann and Jen. That's 2. We could have a team of Ann and Al. That's 3. All right, we've gone over all the teams with Ann on it. Now, how about all the teams with Ward on it? We've already got Ann and Ward. All right, how about Ward and Jen? That's 4. How about Ward and Al? That's 5. All right, so we've got all the teams with Ann, all the teams with Ward. Teams with Jen, we've already got Jen and Ward, Jen and Al, Jen and Ward, Jen and Ann. We need to add Jen and Al, that's 6. Do we have all the teams with Al?
Yes.
All right, so 6 is the answer. So there is a formula for that Danielle mentioned. It is this. If we have 4 things, we're going to call 4 our n, and we want combinations taken 2 at a time. We're going to call x2, and we're going to put a big letter C so that we know we're looking for combinations. So, all right, we're going to go combination, 4 things taken 2 at a time. And to use this combination formula, I need to teach you this factorial symbol. Does anyone know what this factorial symbol means? This n exclamation point?
It's
So it would be 4 minus 3, 4 minus 2, 4 minus.
it's
Yes,
multiplied.
all multiplied together. So if I were to have this 4 factorial, this equals 4 times 3 times 2 times 1. All right, and that's 4 times 3 is 12, times 2 is 24, times 1 is 24. All right. 3 factorial would equal 3 times 2 times 1. 1 factorial equals 1. And 0 factorial also equals 1. The only tricky part is this 0 factorial. Reason for that, if I were to ask you how many teams of 0 could you have out of these 4, the answer, there's 1 team of 0, and it's no people are on the team. So you would like write on a piece of paper, no one is on this team, here's your 1 answer. So 0 factorial is 1. Don't let that confuse you. 0 factorial is not 0. That will screw up everything. Not make that mistake. Alright, everyone understand this factorial? Alright, so our formula then for combination of n things taken x at a time is n factorial divided by n minus x factorial times x factorial. So let's do our problem. How many teams of 2 out of 4 people could we have? Alright, so we've got 4 is our n, 2 is our x, so 4 factorial divided by 4 minus 2 factorial times 2 factorial. Does everyone agree with me so far? Alright, so what's 4 factorial? 24, I like it. Alright, and what's 4 minus 2? 2. And what's 2 factorial?
2.
2. Yeah, 2 factorial is 2. So this breaks down to 2 factorial times 2 factorial. So 2 times 2 is 4. So we've got 4 in the denominator. Does everyone like how I got 4 in the denominator? I'll pause for a minute. It's really the only tricky stuff. So 4 minus 2 is 2 factorial. And we've got 2 factorial. We know that 2 factorial is 2 times 1. Alright, so this is 2 times 2. That equals 4. 24 divided by 4 is 6. That jives with our answer, right? Alright. Take a breath for a minute. So we've got our combination formula. We know the only tricky part, 0 factorial is 1. If I ask you how many teams of 0 could you have, the answer is 1. And I think that's it for combinations. Take just one breath here. Alright, let's do an example. So suppose Samir is selecting stocks for his portfolio. He has 13 candidate stocks from which he intends to select 8. How many different portfolios of 8 stocks are possible? So he has 13 different stocks. He's evaluated them. They're all like the value fund, the value companies he wants to invest in or whatever his preference is. How many different portfolios of 8 stocks are possible? So what is our N in this situation? 13. And what is our X in this situation? 8. All right, great. See if you can crunch that. Let's get a little practice with your calculators or Excel if you don't have a calculator. Or you can just take a breather and absorb.
How would you plug that into the calculator?
You know what, actually, who asked me that? Yeah, I've learned by trial and error I cannot do calculator tutoring because it distracts me and makes me dizzy. So I can't do it during class, I can do it after class. Or if you have an iPhone,
Yeah.
turn it to the side.
It says X factorial.
Yeah.
I see that.
So put in 4 and then hit the X factorial. Go against my own principle of helping with calculator tutoring.
You have 0.069.
How many combinations? That's 0.0. So 1/6 of 1 is how many combinations? I'm joking with you. That's not the right answer though. It's a number. Like he has, 13 stocks. He can choose combinations of 8. So it's some number. It's like
Yeah.
there's at least one
6,
combination of 8, right?
So you were talking about that right
Yeah. All right.
now.
So what is it? What's the on top? 13 factorial. So that's like 6 billion, right?
Yeah.
All right. So
That's a long number.
So, but you have to do the whole formula. What's your name?
Kyle.
Kyle. You have to do the whole formula.
Yeah.
Just give me 1 second. Let everyone else get it, and then we'll write it out together. ready? If you have the answer, just blurt it out.
1287.
What's that?
1287.
1287 sounds right to me. You like that? 1,287 different combinations. So you want to figure out how to do 13 factorial in your calculator. 13 minus 8 is 7. So you do 7 factorial, multiply that times 8 factorial, whatever that comes out to, and you'll divide that 13 factorial, that huge number, 6 billion or something, divide that by whatever this comes out to, and you'll get 1287. Make sense? Good? All right. So that's combinations. The next thing I need to teach you before we're ready for the binomial is quick notes on probability. The probability of some event happening. You ready to move on to this? Feel free to say no. Take a breath. All right. The probability of some event happening, say rolling 4 on a 6-sided die, that might be what I would put in here, probability of rolling a 4 equals the number of outcomes that are favorable to that happening divided by the total number of possible outcomes. So say the probability of rolling a 4 on a 6-sided die, how many outcomes would be favorable to rolling a 4? 1. There's one way I can roll a 4. It says 4 on the 6-sided die. How many total outcomes are there? 6. So the probability of rolling a 4 equals 1 over 6. This is our fundamental rule of probability. You like that? Okay. Let's think about rolling 2 dice instead of 1. So I'm going to roll a die the first time. I'm going to get a 1, 2, 3, 4, 5, or 6. And then I'm going to roll a second die, and I'm going to get a 1, 2, 3, 4, 5, or 6. Alright, so let's ask ourselves, how many total outcomes are possible in this event of me rolling 2 different dice?
12 sides.
12 is not the right answer. 12 is not the right answer. Yes, the correct answer is 36. All right, 36, because there's 36 possible things that could happen. On the first die, I could roll a 1. All right, and then when I roll the second die, I could roll a 1, 2, 3, 4, 5, or 6. All right, so that's 6 things that could happen right there. A 1 on the first die, a 1 on the second die. A 1 on the first die, a 2 on the second die. A 1 on the first die, a 3 on the second die. A 1 on the first die, a 4 on the second die. That's 6 things that could happen. Then I could roll a 2 on the first die. And there are 6 other things that could happen that I need to add to that. I could roll a 2 on the first die, a 1 on the second die. A 2 on the first die, a 2 on the second die. A 2 on the first die, a 3 on the second die. There's another 6 things that could happen. Then I could roll a 3 on the first die. And then there are 6 more things that could happen the second time I roll the die. 4, 5, 6.
So what are the numbers like in the chart? Like the 8, the 9, the 10, the 11, the 12, like what is that?
Okay, those are the numbers added together. Yeah, I'm going to use that as part of my next example. So the numbers in the middle are the numbers added together. So if I roll a 4 the first die, a 3 the second die, add those two together and I get a 7. For right now, I want you to realize that each of these boxes is a different possible outcome. So how many total outcomes are possible in this event?
36.
36. All right, excellent. So, what's the probability of rolling a 6 on one roll? 1/6.
1/6.
What is the probability of rolling a 6 twice in a row, i.e. the first die is a 6 and the second die is a 6.
Wow.
But there's 3 times that you multiply.
All right, I hear grumblings of the correct answer.
You multiply them.
It's 1 out of 30, it's
Ye-
1 over 36.
Yeah, all right, so the correct answer that we just went over is 1 out of 36. So we know, based on our fundamental rule of probability, that there are 36 total outcomes possible in this event of rolling a die twice. And there's only one way that the outcome of rolling a 6 twice can happen. That's, we roll a 6 the first time, we roll a 6 the second time. There's no other way that can happen. So there's one outcome favorable, 36 possible outcomes. The probability of that happening is 1 out of 36.
Why wouldn't it be like 2 out of 36 though? 'Cause it's like 2 rolls, right?
Okay, I hear what you're saying. So,
Like that's
but,
what I
is,
would've.
but there's only one way. Tell me another way, Danielle, that could happen. Let's, is there any other way that I could roll a 6 twice besides rolling a 6 the first time and rolling a 6 the second
I
time?
mean, I just like I consider that like 2 tries. So I would have like on the homework if that was a question I still would have put 2 out of 36. And I would
Okay,
have gotten it wrong.
all right. Well, let's look at it this way. 6 and 6, that adds up to 12. All right, so I'm going to give you 2 dice to roll. All right, and I want to know the probability of both those numbers adding up to 12. How many ways could that happen?
You roll it a couple of times. 6.
You're going to roll it twice.
It's
Okay.
like a 6 and 6.
It has to be 6 and
So
6.
that's like 1. Okay.
Could you get like a 4 the first time
Yeah.
and an 8 the second time?
Yeah.
Could that happen? No, it can't happen. There's only 6-sided dice. You can't get a 1 the first time and an 11 the second time. You have to get a 6 the first time and you have to get a 6 the second time. Of these 36 different possible outcomes, there's only one that amounts to a total score of 12. All right, so the probability of rolling a 6 twice in a row, answer is 1 out of 36. We're good with that? All right, let me cover up the answer here. What is the probability of having 2 rolls add up to 8?
5 out of 36.
36, can you see that? You have it on your slides. All right, so tell me about these 2 numbers. How did I get the bottom number?
Total.
Total and sample space, total number of outcomes. How did I get the top number?
2 and 6, 3 and 5, 4 and 4.
Yeah, the total ways that these could add up to 8. Well, I could get, what's your name again?
Christine?
Christine or Chrissy?
Christine.
Christine said I could get a 6 and a 2, I could get a 5 and a 3, I could get a
4 and
a
4.
4 and a 4, I could get this, I could get this. So 1, 2, 3, 4, 5 different ways this could happen over total outcomes of 36. And you could divide that on your calculator, it comes out to, I don't know, 0.114% or something like that.
0.13.
Yeah, about
13%. Okay, sorry, I was off by.
1.
Any questions on that? Wait, 0.138? I was only off by 0.2%. Okay. All right, somebody mentioned earlier that there's this multiplication rule. So instead of saying, what's the probability of getting a 6 twice in a row, instead of calculating all 36 possible outcomes, I can look at what's the probability of getting a 6 one time, what's the probability of getting 6 the second time. They're both 1/6. I can multiply those together and get 1 over 36. I'm going to show you this on the slide. I just wanted to give you a preview. So 1/6 times 1/6 equals 1 over 36. You just multiply the numerators on top, multiply the denominators on the bottom. Everyone's good with that? Okay, so instead of doing this whole chart, I just could have multiplied 1/6 by 1/6 and gotten the answer that way. This is the multiplication rule of probability. Find the joint probability of 2 events occurring together. we need to multiply the probability of the first event by the probability of the second event. Multiplication rule for independent events. Independent means the second rule is not affected by the outcome of the first rule. They're completely independent. So this, you don't really need to know this symbol for this class, but this upside down U is called intersection. This means both of these events happening. This event and this event happening. Rolling a 6 the first time, rolling a 6 the second time equals the probability of the first event happening times the probability of the second event happening. You like that? Good? Okay. So let's go through some thought experiments using basic rule of probability, and then we're going to throw in the combination rule. All right, suppose you have a 6-sided die. What's the probability of rolling a 6? 1 out of 6, yeah. One single die, probability of rolling a 6, 1/6. Perfect. What is the probability of rolling a 6 twice in a row?
1 out of 36.
1 out of 36. What's the probability of rolling a 6 3 times in a row? Sounds right to me. Yeah, 1 out of 216, so that's like about 0.5%. That's right, just multiply it. I could go on, 4 times in a row, 5 times in a row. You've got it, just use the multiplication rule. What is the probability of rolling a 6 and then not rolling a 6? Oh God.
Would be what, 1 over 6 times 5 over 6?
Yes, perfect, that is correct. 1 over 6 times 5 over 6. All right. So the probability of rolling a 6 the first time is 1 over 6, and the probability of not rolling a 6 the second time, there are 5 ways that that could happen. All right, 1, 2, 3, 4, and 5, and there are 6 possible total outcomes. The probability is going to be 5 over 36. What did we say? That was about 13.8%. All righty. Is everyone good there? This is key. This point is key to our next steps. Probability of rolling a 6, probability of not rolling a 6. All right. What is the probability of rolling a 6 and then not rolling a 6 3 times in a row?
So it would be 5 over 6 and 5 over 6.
Like that? Yes. All right, that is correct. So the first time, probability of rolling a 6, not rolling a 6, not rolling a 6, not rolling a 6.
125.
All right, what's it? Want to give me a decimal point for these? This is 0.138. And what's the can somebody give me the decimal point here? 0.096. All right, so about a 9% chance, 9.6% chance of this happening. You're gonna roll a 6 the first time, and then you're not gonna roll a 6 the next 3 times. All right. Now, what is the probability of rolling a 6 exactly 1 time out of 4 rolls? How do we answer this question?
Is that not the same question?
Okay, so this, we roll a 6 the first time, and then we don't roll a 6 the second, third, and fourth time. Now my question is, Well, what if we rolled a 6 here and not here, here, and here? All right, what if we rolled a 6 the third time? What if we rolled a 6 just the fourth time? So out of 4 times you roll the die, I want to know the chances of one of them, and only one of them, being a 6.
1 out of 4.
Isn't it just still the same numbers, just maybe in a different order?
Yeah, you're on the right track. Okay, so it could happen this way, and there's a 9% chance. Let's think about another way it could happen. What if it happened the second time? We could calculate that probability, right? We would say 5 over 6 times 1 over 6 times 5 over 6 times 5 over 6, and it would be the same thing, right? It would be 0.096. And we could add that. We could add this to this, and we say this is the probability of rolling a 6 this time or rolling a 6 this time. And then there are 2 other possibilities we need to consider, right? What if we roll a 6 on the third roll? And what if we roll a 6 on the fourth roll?
So we just do 0.096 times 4?
Yeah.
Do it like that?
That's right. That's the answer. 0.096 times 4. Because there are 4 different ways that this could happen. The probability of it happening each time is 9.6%.
How'd you get that number again? You could just work that.
The 4 or
is
the-
Is that the bottom part right there?
The 0.96?
For
0.096?
question, the recent question, the probability of rolling is 6 exactly 1 time out of 4 rolls.
It's this times 4.
That times 4. Okay.
And I'm gonna continue to go over this because I'm gonna show you a different way to come up with this. So it's 0.96 times 4, which is what, 38%? Yeah, so there's a 38% chance that out of the 4 times you roll the die, one and only one of them will be a 6, excuse me. Now, we were able to do that one in our head. We knew that there are 4 ways that it could happen, and we knew the probability of it happening each time. Suppose I were to ask you, is there a way we can use that combinations formula that we just learned to get to that answer faster? Yeah. How might we use that combinations formula to get to that answer faster?
4 would be N.
Yeah, something like that. So
And
n
X
would be 4.
and then
Yes.
X would be 6.
1.
1.
1. Yeah, that's right. So there are 4 different rolls, and we want to know how many different combinations of 1 there are. So we want 4 combination 1. Give myself some room to work this out here. 4, 1. 4 different rolls. Question is, how many different combinations of 1 are there? So this is a little funny the way we're asking this. I don't know if you've ever heard someone say how many different combinations of 1 are there. It'll make more sense when we do combinations of 2, or it'll just sound more logical. But the math works for this as well. So, 4 things, combinations of 1, 4 factorial over 4 minus 1 factorial, 1 factorial. 4 factorial is 4 times 3, which is 12 times 2 is 24 times 1, 24 on top. 4 minus 1 is 3. 3 factorial is 3 times 2, which is 6. 1 factorial is 1. So 24 over 6, 4. Okay? So we know that there are 4 combinations of 1 out of 4 different trials. So how we got to the answer is we took 4 times the probability of it happening each time, 0.096. And we got our answer of 0.38. All right, how are we feeling with that?
And you got the probability with the 1 times 6, and then 5 times 6, 5 times 6, yeah.
Yes, 0.096, 4 times. All right, we're good there? All right. What is the probability of rolling a 6 twice out of 4 rolls? How are we going to calculate this problem? Twice out of 4 rolls. So I'm going to roll the die 4 times. I could get a 6 the first time, then 6 the second time, and then not a 6 the third and fourth time.
So you do the same thing, but replace 1 with 2.
We do the same thing, except we replace 1 with 2. So let's do our combination. 4, combination 2. All right, and we know from our earlier work that the answer to this is 6. How many different teams of 2 out of 4 people could we have? But let's just go ahead and crank it out anyway. 4 common factorial over 4 minus 2 factorial, 2 factorial. 4 factorial is 24. 4 minus 2 is 2. 2 factorial is 2. 2 times 2 is 4. All right, okay. And 24 divided by 4 is 6. So we know there are 6 different ways that this could happen. What's the probability of it happening each time that it does? What's the probability of rolling a 6 twice and not rolling a 6 twice? What you can do is you can pick any individual way that it might happen. So it might happen that we get a 6 the first time, probability there is 1/6. A 6 the second time, probability there is 1/6. Not a 6 the third time, and not a 6 the fourth time. That's a way it could happen, right? And there are 6 different ways that that could happen, and I would just rearrange all that. Okay, so 1/6 times 1/6 times 5/6 times 5/6. Somebody have the answer for me?
0.019.
0.019. All right. So, in order to answer this question, what is the probability of rolling a 6 twice out of 4 rolls? I'm going to take the number of combinations, ways that that could happen, times the probability of it happening each time. So I'm going to take 6 times 0.019. All right, how are we feeling with that? I see some people ready. We can take a minute.
0.077.
Oh, okay, 6 times that. Thank you.
Do you do that times 6 or times 4?
Times 6.
Oh, okay, then that's wrong.
Never mind. Okay. 0.114. Okay, so about 11%. 0.11. 0.114. 11.4%.
And that's the probability of rolling a 6 4 times?
Probability of rolling a 6
4 different rolls.
twice out of 4 rolls.
That's not the question, right?
So then for the next one, it would be combination 4 and 3.
Yeah, you're on the right track, Dan. Yeah,
You would get the number of combinations, and then we would just set it up again with like,
Yes,
with what we did, but just with one more,
yes.
5 out of 6.
This would be 1/6 instead of 5/6,
Yeah.
and this
Maybe
would be,
multiply it again.
this would be 3 instead of 2?
Yeah.
Yes, exactly. And I think you had a question that, the question we're asking is the first one. What is the probability of rolling a 6 twice out of 4 rolls? Alright, so we need how many combinations? We could get
Like
2,
those things, right.
and then the probability of it happening each time comes out to.
Right, so then, what about the next question, 3 times, 4 times, what's the answer for that though?
Okay, so Danielle got us started on that. What we're gonna do is we're gonna put a 3 here instead of 2, because we're looking for it happening 3, combinations of 3. And so this is gonna be a different number.
And you would just do the same for 4 for the next question.
Yeah, so we'll put a 4 here instead of a 2, and then this will be 1/6, 1/6, 1/6, 1/6. Because we'll have to roll a 6 4 times out of all 4 rolls. Does that make sense? Alright, any questions? Alright, so that is our binomial probability function. The probability of x, which is the number of successes. In our example, it was the number of times we roll 6, equals the combination formula. N is the total number of rolls, x is the number of times we want to get a 6. So we do the combination formula. And then we do the probability of a success. In our case, it was 1/6 times however many times we want that to happen. And we just raise that to the power of x. So, in this example, it would be 1/6 raised to the 2. 1/6 squared instead of 1/6 times 1/6. That's what this little power means. Probability of it happening 1/6 raised to however many times we want it to happen, times the probability of it not happening, which is 1 minus the probability of it happening. In our case, this was 5/6 raised to the n minus x. So this is the number of times that it doesn't happen. So for our first example, rolling a 6 once out of 4 rolls, alright, it would be 4 would be n, x would be 1. We would do the combination formula, and we would get 4, right? And then the probability of rolling a 6 is 1/6 raised to the first power times 1 minus 1/6, which is 5/6 raised to the third power. Make sense? I'll just write it right here. Should I just do it?
Yeah.
Alright, so the probability of rolling 6 once. Rolling 1/6 out of 4 rolls. Alright. Alright, so we've got 4 factorial over 4 minus 1 factorial, 1 factorial, times 1/6 raised to the 1, times 5/6 raised to the 3.
You got 3 because 4 minus 1?
Yes,
It's rolling 1/6 out of 4 rolls?
yes. Rolling 1, sorry, my writing's a little messy there. Rolling 1/6 out of 4 rolls. Alright, do we like that? No? Do we understand that?
This just shortens that process, right?
Yes, yes.
that's, so the one, sorry, the one's like part of the formula, right?
The what?
The number one is part of the formula, right?
Yeah, 4 minus 1. So, yeah,
So that's
actually I can write it up here. So probability of 1 equals, yeah, probability of x is 1. I could put probability of this is, x is number of successes. Alright, if I define success as rolling a 6,
It'd be
then
a 6.
it'd be 1. No, 1
No.
success.
One success, always one, okay.
Yeah.
Right.
And then here, this is 2 successes. I put in 2 for that. And then we could do 3 successes just like Danielle told us.
Right.
Alright, everyone good here?
What was that, 5/6, the last one? 5/,
Yep, 5/6, 6. And instead of writing it out, 5/6 times 5/6 times 5/6, I'm gonna raise it to the 3rd power. Does everyone understand that? Raise it to the 3rd power? Alright, great. Alright, I think I have an example here. This is some fine print. The binomial, the first part is the combination that we went over. This is combination, and this is the probability of it happening each time. How many combinations, how many ways can it happen, probability each time. Like I said, some footnotes, fine print, it's just number of trials, what we consider a success, assuming the trials are independent, and the probability of success, and then we assume the probability remains constant in all 4 roles. Okay, let's do an example. The Wall Street Journal reports that 42% of approximately 3,500 stocks traded yesterday on the New York Stock Exchange advanced, that is increased in price. So 42% of stocks went up. If you had randomly chosen 4 stocks at the start of the day, how likely is it that all 4 stocks that you had chosen would increase in value? So, you're going to choose 4 stocks. The probability of success would be 42%. And the first question is, what is the probability of 4 successes in these 4 stocks that you chose? Kind of like rolling a 6 4 times. All right, start working on that. Let me erase some stuff and make some room. Okay, ready to do it together? So, probability of 4 successes. We need how many combinations of 4 could we have? So, oh wait a minute. 4, yeah, sorry. Alright, yeah. How many combinations of 4 out of 4 things could we have? What's the answer to that, by the way? If we have 4 things, how many combinations of 4 could we have? One of those.
16?
It's-
Four.
No.
100%.
Suppose we have 4 people, how many teams of 4
One.
could we have?
One.
Yeah, the answer is 1. Sounds complicated because I've taught you so much. I've taught you to question yourself at this point. So there is 1 combination of all 4. If you were to crank this out, this would be 4 factorial. 4 minus 4 would be 0 factorial, which is 1. So it'd be 4 factorial over 4 factorial, which would be 1. Probability of success is 0.42. We raise that to the 4th power. Probability of failure is 0.58. We raise that to the 0 power. Anything raised to the 0 power is 1. Alright, if you know the answer, just blurt it out. So this is 1, this cancels. This 0.58 to the 0 power, that's 1, that cancels. So all you need is the 0.42 raised to the 4th power, right?
0.03111.
0.0311. So about 3%. About a 3% chance of this happening?
So what did you say cancel out?
This is 1. How many combinations of 4 out of 4 stocks could you have? The answer is 1. So this whole thing is 1. And this part, the 0.58 raised to the 0 power, that's 1. So the only thing we need is to worry about is the 0.42 raised to the 4th power.
The 0.58, did you get that from the problem, or did you subtract 1 minus
Yes,
0.42?
Both. Both. It was given in the problem, but we could also confirm that by subtracting 1 minus 0.42.
Okay.
I guess yeah, I guess we wouldn't even worry about that. Good point. We wouldn't even worry about this because the formula says 1 minus this.
Yeah, I just wasn't sure if it was a coincidence or not.
Yeah. It's not a coincidence. We would follow the formula and we would subtract 1 minus this. But yeah, it would be, I guess it wouldn't make sense to the problem if it happened any other way.
Alright.
So it has to be that way. Okay, we're good there? Alright, let me see what's next. We're gonna take a break momentarily, but just let me finish off this. Okay. Let's think about these next 2. Let's just intuitively think about how we would solve them without doing the calculations. So what's the probability that exactly 2 of the 4 stocks you selected increased in value? How might we set that one up?
So n would still be 4, but x would be 2. So it would be like the same equation, but with those numbers.
Exactly. So the probability is still 0.42 each one. N would still be 4, x would be 2. So we would put in 2, and we would crunch those numbers. This one's a little more complicated. No more than 1 of the 4 stocks you selected increased in value. So what does no more than 1 mean? Actually, don't even worry about that. It's a thought exercise we don't need to worry about right now. You know how to do it because you actually calculated this one out, and if you wanted to know how many probability of 2 stocks advancing, you would just put 2 in for x instead of 4. All right, so I'm gonna talk about this next slide, and then we're gonna take a break. This can be graphed in our first probability distribution. So this graph is probability, chances of stocks increasing, the chances of 0 stocks increasing, 1, 2, 3, or 4 of those stocks increasing has a certain percent likelihood. You just calculated the chances of all 4 stocks increasing. And you can see looking at the graph, it's about here's 5%. So that looks about 3.11%. You believe me, right, that this is 3%? The chances, this one, this here, the chances of all 4 stocks increasing is about 3%. How about the chances of 2 stocks increasing? What's the probability of that happening? Yeah, about 36. All right, what are the chances of 0 stocks? So you pick 4 random stocks at the beginning of the day. What are the chances that all 4 of them decrease? 0 stocks increase. What's the probability of that happening? How much? Yeah, about 11%. All right, and how about 1%? What's the probability, 1 stock advancing?
32?
Yeah, 32. So we've got 11, 32, 36. The probability of getting 3 winners is about 17%, and we calculated the probability of 4 at 3% exactly. Or we calculated 3.11%. So I just want you to be comfortable with this. This is a probability distribution. We're going to change courses. We're not really change courses. We're going to build on this. Just make sure you understand that we can graph this probability of a certain outcome on the actual outcome on the horizontal axis. It could be 0, 1, 2, 3, or 4. And the probability of that happening on the vertical axis. Probability distribution. Make sense? Okay, great. 10 minutes a good break time. I find that's enough to take a little break, but the sooner we get through it, the sooner we can go home. Does that work well for you? All right, so let's come back at 8:18.
So he records his lectures, we can just go on there. And you know what, Larry? They made you work on
Yeah, today, another,
I don't know where the class is.
I was like, you know what, I'm just gonna go here, and I went to the main campus, the girl had to leave because I was like, I'm already going. So now that I know, I know. I was like, my first day of this, I'm like, oh yeah, I wanna do that.
You know what, he records everything. So we can go on there and we can play
Yeah, when I came in, you
everything.
were showing that, we're gonna just go on,
You go on the Blackboard.
Oh, the Blackboard.
Yeah.
And you go to his
There's a
specific
link for it. You
class.
sign up, and before you sign up, you go to Blackboard,
Uh-huh.
put your credentials, like, and then you go to University Today.
Yeah, the username and all that stuff.
Course, make sure you put on the right course, and then the course you're taking.
True,
Then
true.
you go to the assignments, and you just click on things, and it'll show everything in there.
Okay, good.
Yeah.
So, yeah, it was good. And this visit, you guys good here? You guys did good? Because where's your first time?
I was struggling to get 60% on that con, so, and it was good.
I know, right? Everything else, like, all right.
And like, if I'm like, I wanna see another guy.
I know,
I wanna see dice, I wanna see, I wanna see the cards. No, I don't wanna see that.
No.
Actually, I find it easier, like with this Wall Street thing, like this looks, like this.
You can read through it and then just
Like
kind
the
of
other one,
like.
you gotta really think, okay, when the camera
It's not-
you throw that.
Yeah.
4 minus 4,
Yeah,
which
like
is
think
0.
about it.
I'm like, oh my gosh. Oh, you know, I need to.
This is like the second, it's just supposed to be the same thing. Just one. Who has the book? Anyone have the book?
Yeah.
Yeah. Just wanted to compare. I got an older version.
Oh, okay. I just got this today, so.
Yeah.
What's the 20?
Can I just take a quick peek if you don't mind?
Yeah. It's all loose leaf.
Oh, okay, I'll be careful.
Yeah, that way I'll just really just focus on this one. Yeah, that's gonna be a little bit easier, like I don't have to like worry.
I got an older version.
So where'd you get yours? You got it from the store?
No, I got it from Amazon.
Amazon?
I got, well, this is someone else, I got an older. It is, yeah, I'm actually comparing it now, it looks like to be the same. I paid $40.
How much is it? 140? Yeah, so I will be,
I paid,
I know.
I paid 45. It seems like the same thing though. It's the second
I'm
edition.
pretty sure, like.
I get the book and the back I stick it at $3.99. Yeah, they got it for $3.99 and it sold to me for 45.
That's really not really that much of a difference, it's just how you rearrange.
I mean, what they changed, just one word?
Yeah, that's the.
You get a digital.
It is, that's just the instructor as well.
Same thing. I Googled to see if it was the same thing. They said it was the same thing. That's why I got it. I wasn't sure.
Yeah, but that one says that they will get it between December and the 20th.
Right, because now it's like the holiday season.
Yeah, it's the same thing.
What is starting to know?
Only we use like 10 weeks. That's a lot of money. Exactly. A lot of money.
Rent it though.
Yeah, I'm definitely going to do that.
That's what I think I'm gonna do.
Yeah.
Because I know once you make it to certain classes, I'll be scared to look at the book again. This right here. This is the fifth grade.
There's a bookstore here. I think most people rent it from Shay. I think you can rent it here.
That's where I was done. Leah.
What's the book?
Shane? Shane. CHEGG, because I remember the kids in college that did that. That's what I'm gonna do.
Someone left their USB in this computer.
Ricardo, is there Ricardo show up? Jasmine?
I have to just review it
Precious.
one more time,
Right,
just
yeah.
in my case. It's pretty, it's easy, it's just, it's still. Cause all this was under contract.
Yes.
That's true,
They had those scenarios where, they even had the Wall Street one there too.
Yeah.
And they had one where voting like if you keep your friends, how many did you get to?
Right.
That was the combination.
Morinette. Am I saying that right?
Yes, but you can, it's Maury, I thought they had shortened it, it's Maury, it's easier.
Maury?
Maury, yeah.
Maury, okay. Maury. Alright. So just no Ricardo and no.
Oh, right here.
Oh, Ricardo.
Yeah, you want to take a picture of it?
Alright, just no Jasmine.
That guy, that's one.
He said he was in regular interview, and he said it's not much difference.
Oh, yeah.
And he gets full
Because I guess, you know, all of this stuff is being created, it's not in the book, it's just
Right,
quizzes are on the computer, that's just this.
right.
So you know the concept, you know. You need the book, but. Yeah, I need to make sure I have one.
Just excuse me, I'm gonna check this camera. Worried about whether or not it's at the right angle.
Professor, you record all your lectures then, right? And it's
Yes.
on our blackboard and we can go.
Ah, yes, yes.
Okay.
Alright, looks like we're good. Just can't stand too far that way. Yeah, they're all under class video recording, under my
The black course, yeah.
yeah, my course or whatever,
Right.
course materials,
Right.
that's it. Alright, so let's get started. So tonight, it looks like we're gonna go pretty close to 9:30. I will definitely make an effort to do one of two things, either get you out a little bit before 9:30, or if we go all the way up to 9:30, at least make sure you're learning something important. Tonight's one of those nights, we probably will go right up till 9:30, yes?
So the stuff we're doing now is for the test, that's the next week?
Yes, yes, yeah, so they'll, on the syllabus on page 3 and 4, there's homework problems associated with this and with other things I'm gonna teach you in the next hour. Do those homework problems, you should be all set for the test. If you have any other questions, you can ask me. I don't know if you saw me go over the Excel worksheets and all that, I can show you that after class. Alright, so before the break, we learned the binomial probability distribution or binomial probability function. We use that to calculate number of successes, and we came up with our first probability distribution. Probability distribution has a couple of important features. On the horizontal axis, it has the outcomes. On the vertical axis, it has the probability of that outcome happening. Alright, so what I'd like to do now is use the binomial distribution to create another probability distribution. I would like to use an example where we are flipping a coin, a fair coin. Suppose we flip it 20 times. The probability of it coming up heads each time is 50%. And what I'd like us to calculate, we won't do them all, we'll do a couple. I would like to calculate the probability of 0 through 20 successes. So let's do one together. Suppose we want to calculate the probability of 11 successes in this 20 coin flip experiment. So we're going to flip a coin 20 times. I want to know how likely is it that 11 of those coin flips will come up heads. Does everyone understand the question? All right. So what is our n in this scenario?
11. 20.
20, yes. What is our x in this scenario?
11?
Number of successes, exactly. What's the probability of success each time? 0.50, outstanding. So, all right, the probability of 11 successes equals 20 factorial divided by 20 minus 11 factorial times 11 factorial times 0.50 raised to the what?
11?
Outstanding. Times 1 minus 0.50, which also happens to be 0.50 raised to the what? 9. Outstanding. Perfect. All right. So, does anyone have the answer? If not, I don't want to wait for it. It's going to take a while. Just move on. I'm impatient like that. All right. So that's how you would.
0.002.
0.002. So about 0.2 of 1%. No, that's not right. I don't think. Alright, so actually maybe I'll assign someone to do this one and actually get an answer. Maybe, could you 4 in the front row, could you do this one? Probability of 11. Maybe could you 3 in the back, could you do 12? The probability of 12 coin flips coming up heads. Probability of 12 equals. And maybe could you 3, could you do 9? Probability
Factorial, that's why.
of 9. And then maybe you 4 in the back row, could you do, let's say, what have we got? We've got 11.
12, 9.
Let's do 10. All right, you in the back row, do 10. All right, so you all in the back row are doing 10. You 3 are doing 9. You 4 are doing 11. You are doing 12. All right.
Oh, yeah, it would be, put the X would be 10 instead of 11. Yeah.
Then we just times it.
Feel free to confer with each other. As long as you're on the same team.
I didn't do that.
We would just run this.
How you coming?
I missed the factorial on the other one.
Okay, so that's 2.5 times 14, which is trillion.
I don't know, like, that's why I'm like,
It's a percentage between
Supposed to equal
between
20.
zero.
Yeah, we're doing 9,
So this is going
yeah.
nine.
Yeah.
Alright, how you coming?
Did I fit on my phone?
What'd you get?
that's the thing, it's not.
12.6?
This one.
17.6, that looks right. Yeah, 17%.
Professor Johnson?
Yeah.
With this one,
Because there's 20.
the 25 for like a crazy.
Yeah, that's like 2.4 trillion times
But
two
it's
to
like
the
2.5
So what I did was I figured out, and the other one
So we try to try 5 factorial.
Right.
So 20 minus 11 factorial is 3 minus 62.
That's right, so 5 factorial is 120. So,
Wait, so, yeah, that's what I get
I might be doing
like
this
2.4
wrong,
trillion.
because I have 4.
okay, alright, so it's not 2.4 trillion. Billion trillion, actually. It's like billion zillion
Yeah.
trillion.
Yeah.
Alright, who's got a reasonable answer for 11? Reasonable answer should be between 0 and 1.
Yeah.
And then you divide that number.
Alright, that one? Reasonable answer for 12?
You should like 180.
Come on, for 11 I even wrote it all out for you. Still didn't get it? It's
See, when
fine.
you-
It takes a minute to get used to the calculator. Like I said, I can help you a little bit after with your calculator if you like, or you can just kind of get used to it between now and next week. Maybe you'll probably want to do it on Excel. That might even be an easier way to do it. All right, anyone have a reasonable answer for 12?
12%.
0.126? Is that, it's just 12%?
I didn't go that far.
I-
Oh, that's all right, that's fine. Okay, I like 12%. How about 9? No.
I set it up beautifully, but I don't know what I'm doing wrong on my calculator.
Okay, anyone got 10? Oh, yeah,
17.6%.
17.6%. All right, excellent. So I've got all these calculated out. So for 12, the answer is I get about 12%, which is right. Yes. For 10, I get about 17.6%. Yes. For 11, if we'd gotten that far, I'd get about 16, just a little under 16%. And what else are we missing? For 9, the answer should have come out to just a little under 16%. So we may not have gotten all these answers, but we got a few of them, and you knew how to set these up. So if you had some more time, you could crank out each of these. The probability of 0 successes, flipping the coin 20 times and getting 0 heads, would be this tiny, tiny percent. Can't even see it, it's so small. And all the way up through 20. Let me give you a minute to absorb that. We'll talk about what that means. Does everyone understand at least how we would have constructed a probability distribution like this? So,
Can you just do the first part of the probability of 12?
yeah, sure.
Can you write out the whole formula for 12?
Just the first part, because these numbers are so.
All right, so the probability of 12 successes. First, we need, how many combinations of 12 out of 20 coin flips could there be? So when we're flipping this coin, we could flip all 12 first ones, be heads, and then 8 tails, or any other sort of combination of that. So that'd be 20 factorial, 20 minus 12 factorial, 12 factorial, times 0.5.
I just want you to do that part right there, the first part, before you go.
Oh, you want me to do this?
Yeah, because I got the rest of it.
Okay, fine. All right, so 20 factorial over 20 minus 12 is 8 factorial, 12 factorial. All right,
My numbers are so large, that's.
yeah, this is like 20, that's like 7 zillion.
Okay, so it's not just.
So you need to keep it in your calculator,
Uh-huh,
or you need to do like parentheses or something like that.
uh-huh.
Yeah, we're doing it in Excel.
Yeah, see, I'm doing it too, and I still keep getting huge numbers. Like, I'm
Me
getting
too, that's
exponential numbers.
Yeah, but on that TI thing here, you can
Yeah.
do parentheses is probably the way to do it. I can't do it. I'm gonna get dizzy and confused.
Oh, no, I can, maybe I should try parentheses then.
Yeah, parentheses is a good way to do
So
it
do
there.
they all go in the parentheses, the X?
These, well, so what you'll do on your calculator, you'll do 20 factorial divided by parentheses, 8 factorial times 12 factorial parentheses.
That's a scientific calculator.
Okay, so it may take a minute to play around with that calculator, but you should definitely invest that time doing that. It's just something a MBA student needs to be fluent with.
Is it
Right, didn't
125,970?
The answer? No, it's a number between 0 and 1, and for 12 it is 12%.
It's 12% for as well.
Eerie coincidence, isn't it?
Oh,
So we'll call it 11.99%.
Got it.
Okay, all right, so let's take our focus off the calculators for a minute. Definitely something you need to invest some time into to get fluent with, but let's try not to do that right now. Let's just first pose the question, are you comfortable with how we would have gotten all of these numbers? No, who can blink first? All right, you are, right? We just put them in the binomial function that we all know and love now. For 11, we'd set it up just like this. And imagine you put the parentheses in your calculator the right way, you would have gotten the right answer.
Is there a quicker way to do that than do it 20 times?
Do what, 20? Oh, yeah. I don't know, you could do it in Excel, you could do some sort of pivot table. Yeah. I think that's what, I did the to build this graph, I did the formulas, and then I don't know what I did. I didn't do it 20 times, I like, you know, I wrote out 1 plus what I don't know what I did. That make sense?
Sort of.
So I wrote out 1 through 20, and then I did some sort of combination formula, and then I set up some formula. In fact, I think you may even get to do it for your homework for Excel.
Alright.
All right, so again, are we comfortable with the way you would have gotten these numbers? So if I ask you, what's the probability of 5 successes flipping a heads 5 times out of 20 flips? Are you comfortable with how you could have told me the answer is 3%, or on your calculator it would have read 0.03 something? All right, no one's gonna say yes. Maybe I can ask the question a different way. So silence means yes. Yes? Yes? You can lie to me, it's all right. Just say yeah.
Yes, yes.
Yeah.
We can get how to set it up, we just don't get how to solve it, because like,
Yeah,
the
that's
calculators
the
are not
problem. These
helping.
numbers are huge.
Yeah.
All right, so
But I
then,
think we can all set it up.
You can write a formula out.
Yeah.
Yeah.
The formula we understand.
Yeah.
all right,
It's just solving it.
understand the formula. Your challenge between now and when you take the quiz for this class is to make sure you can do that on your calculator, or you can do that on Excel. Because you'll have a problem exactly like this. It'll be like, what's the probability of so many successes out of so many trials, if the probability of success each time is whatever percent. It'll be just like that, and you'll need to give a percentage. Okay, so we know how to set it up where each of these, we could have calculated these. You all have the skills to calculate this probability distribution. So, once you've done that, and we didn't quite get there, but once it, Precious, if I could have you paying attention for right now. I know it's tempting, but, so once you've done that, what have you created? What is that?
A bell curve?
Bell curve. All right, a normal distribution. You have recreated the most important statistical discovery in this field. The standard normal distribution, a normal bell curve. Let me ask you a couple questions about this. suppose I were to have you all go home tonight and do this experiment. Flip a coin 20 times, write down the number of times it comes up heads. So you're gonna do that tonight. Flip a coin 20 times, write down how many heads you get.
Is it
Some of
serious?
you, no, but suppose, suppose I work. Alright, you're gonna write down your answer, you're gonna get like 8. Danielle's gonna get like 7. Christina's gonna get 12. Alright? And when you come back next week, suppose we were to graph the answers that you got, the results you came up with on a probability distribution. What do you think that probability distribution would look like?
Probably not.
It would look a little bit like this, but it wouldn't look perfectly symmetrical like this, because there's only 15, 20 of you. What if instead we were to ask every single Mercy College student, I think there's like 11,000 Mercy College students, we were to ask them, can you go home, flip a coin 20 times, write down the number of heads you get, and then we were to graph those 11,000 points of data.
It would be more like that.
It'd be similar to
It would pretty much look exactly like this. Law of large numbers. All right, another question I might ask. Suppose someone comes to you and says, you'll never guess what happened last night when I was flipping that coin. I got 16 out of 20 heads. What is the probability of that happening? 16 out of 20 heads.
Like 1%.
Very
Really,
simple.
really
You
low.
just divide it, right?
Well,
0, 0, 1.
it's this, right? You can first just read the probability, like, it's about, we'll say 0.5%. There's a 0.5% chance of that happening. All right, that person who flipped a coin and got 16 heads out of 20s, what percentile were they in? Were they in the top 1%? Were they in the top 10%? Were they in the bottom 5%?
Top 1.
Top
Yeah, they're close to the top 1. They're actually in somewhere in the 99th percentile. You might say to that person, wow, you were in the 99th percentile. The chances of you getting that many heads are less than 1%. So what we'll find is this normal distribution has predictable qualities like this. So this we can calculate because we know the probability of getting heads or the probability of getting tails. Suppose instead we were graphing the data of, say, trees in a forest, the height of trees in a forest. So we were to measure 10,000 trees in a forest. We were to take the average height. The most common height would be this one, the one in the middle. Some of those trees would be a little bit taller. Some of those trees would be a little bit shorter. Some of those trees would be a lot taller. Some of those trees would be a lot shorter, and so on and so forth. Now I will tell you, a lot of natural phenomena have this normal distribution, have this pattern. The reason they have this pattern is because the probability associated with a tree being a little bit taller or a little bit shorter is something that equates to a 50-50 chance of flipping a heads or flipping a tails. One tree may have gotten a little bit more sunlight. One tree may have gotten a little bit more water as it ran through the canyon. One tree may have had genetics that weren't quite as good. It's certainly not as simple as a 50-50 coin flip, but there's probabilities associated with that. And if we have 10,000 trees in a forest and we measure the height of all of them, it's very likely we're going to get a perfectly symmetrical bell curve. And when we have a perfectly symmetrical bell curve, we'll find all we really need to know are two things. What is the mean? What is the average height of those trees? What is the average number of coin flips? And how dispersed is this data? Is this bell curve tall and skinny? Or is this bell curve short and fat? So we know those two things, and we know that this data forms into a normal distribution. We can make assumptions such as that tree is in the 99th percentile. Or we can say there's only a 6% chance of a tree being that tall. Those are the kind of things we can assume and we can calculate if we know that the distribution is normal and we know those two things. The mean, the center of the distribution, and how dispersed it is, whether it's short and fat or tall and skinny. Does that make sense? All right, no one's shaking their head no, so that's a good sign. All right, so normal distribution. Let's think about how we quantify this bell curve. And I want to point out, I mean, I know there was some frustration when we were doing the calculations, but you did kind of calculate that bell curve. We got a couple of the right answers here. We did, and we got a couple of the correct setups for answers. We didn't quite get all there, but you calculated this normal distribution. And once you've calculated it, there are certain things we can assume about it because it falls into a normal distribution. And so then we're going to talk about how we quantify a normal distribution. We'll talk about mean, medium, and mode, standard deviation. Standard deviation is just another way of saying short and fat or tall and skinny in terms of that bell curve. We're going to talk about z-scores, which is a standardized way of looking at data, and the assumptions we can make if we have a normal distribution. So first, let's talk about the mean, medium, and mode, and standard deviation. We call these three things measures of central tendency. Mean. What is the mean of a pool of data?
Average, right?
Mean is the average. That is correct. So what was the mean of that pool of data when we flipped a coin 20 times? What is the mean number of heads that came up? Assuming we had 10,000 Mercy College students do it. And we reported that data and we graphed it on a distribution. What is the?
10.
10 is correct. Exactly. Median. What is the median of a pool of data?
The middle.
The middle number. It would also be 10 again. Because that coin flip example fell into a normal distribution, the mean, medium, and mode are all the same. We'll talk for just 5 minutes about data that is skewed, where the mean, median, and mode are not the same, but that's just a brief conversation. So the median is the middle number. If we were to line up all the numbers, the middle one would be the median. And the mode is what?
Most common.
Most common. All right, for a normal distribution, these are the same. For a non-normal distribution, they don't necessarily have to be the same. Okay, let me just show you some of the notation when we're calculating the mean. If the data are from a population, the mean is denoted by this letter U, this funny looking U. We call it mu. Mu is equal to all the points of data added up divided by the total number of points of data. So if we're measuring heights of trees in a forest, say we have 49 trees in a forest, we add up all the heights of all 49 of those trees, divide by 49, that gives us the mean, mu. Large N is the number of the whole population. Make sense? If we're just using a sample, suppose we have 50,000 trees in the forest, and we're just taking a sample of, say, 35, and we want the mean of that sample data, we use this notation, x with a bar over it. You can call this x bar. You can also call this the sample mean. The sample mean is all 35 of those trees, their heights added up, divided by n, the sample size. Little n is the sample size.
That's 35.
Yep, that's 35. So mu, population size, x bar, sample size, sample size. X bar, sample mean, little n, sample size. We'll use this so many times you'll get used to it quickly. Okay, we're good on mean? Median, as we said, is the middle number. I don't want to discuss that too much, just the middle number, you line them all up, the one in the middle. Mode is the most frequently occurring number. In a normal distribution, that is the same as the mean and the median. It doesn't necessarily have to be. Mode is the most occurring number, and it is the high point of that Bell distribution. So even if it's normal or non-normal, the highest point will be the mode. Okay. All right, so let's take a look at a couple quick examples of mean, median, and mode. Suppose I'm looking at the income in a certain town. And in this case, I know everyone's income in the entire town. And I know that the mean income is 60,000, median income is 60,000, the mode income is 60,000. If I were to graph that data, I would have income on the horizontal axis, and I would have frequency of that income on the vertical axis. And it would be a perfectly distributed, symmetric, normal distribution. The mean, median, and mode would all be 60,000, and I would have normally distributed data on either side of that. So that's one example. Suppose instead, I were to look at a different town, and I were to find that the mean income were 80,000, the median income is 60,000, and the mode income is 60,000. What is going on in that town?
More people making more than 60,000?
More people making more than 60,000. Okay, so that, the way you said that is actually incorrect, and it's tricky, because the median number is 60,000. What does that mean by definition?
The middle.
Middle number. We have 50% making more, 50% making less. So we cannot say we have more people making more than 60,000. But what can we say?
Positively skewed.
We can say it's positively skewed, yes. What that means is there's something about the people who are making more than 60,000. It's not that there's more of them. It's that they make relatively more than their counterparts on the other side of the distribution. So the rich people are really rich, and the poor people are just, kind of poor. Proportionally, the rich people make a lot more. It could just be one person. It could be one really rich woman who lives in town, who pushes the data up, who pulls the mean up to 80,000. There's not more than one of her, but she positively skews the data. Does that make sense? All right. Opposite example. Mean income 45, median income 60, mode income 60. What's going on in that crazy town?
The poor people are really poor.
Yeah, the poor people are really poor, rich people are just kind of rich. Yeah, so maybe we have a section of unemployment, like people who make absolutely nothing. So, and we have normally just, more of a normal pattern on the positive income side. So the poor people are really poor, rich people are just kind of rich. All right, so that would give us an example of skewed data. I think I promised you 5 minutes discussion on non-normal distribution. So that's actually pretty much the only time we'll discuss non-normal distributions the rest of the class. The reason for that is because the normal distribution is really what gives us any power in statistics. If we can assume things are normally distributed, that's the only way we can make predictions. That's the only way we can say that our predictions have any validity, is by assuming that certain things are normal. And we'll take certain precautions, of course, we'll do good sampling, we'll use that assumption carefully. But in order to make any predictions at all, we need that assumption. So, let's get back to our discussion of normal distribution. Before we dive right into that, we've already talked a little bit about this. I want you to answer this question. What is the difference between these two symmetric frequency distributions? Take a look at this one, take a look at this one.
There's less dispersion on the right.
Yes, less dispersion on the right. So these two frequency distributions are both symmetrical, and I will tell you they are both normally distributed. But there's less dispersion here than there is here. Suppose maybe this is income in a town. This might be a factory where everyone works for the same factory and they all make about the same amount of money. Maybe someone gets a promotion, someone's been there 20 years and gets a promotion. Maybe there's some entry-level people here, but everyone makes pretty much the same amount of money. Maybe this is a different town where we have all sorts of different types of folks. We have people who work in factories, we have people who are, you know, Wall Street traders, something or another. We have a wider dispersion of the data. And if you remember earlier when we talked about, when I just introduced the normal distribution, I said we need to know two things about the dispersion of, two things about a distribution. One, what is the mean of it, what is the center of it, and two, the dispersion. So, we want to think about how we can quantify this dispersion. And we do it with a term called standard deviation. The most common way to measure the variation of the data is standard deviation. Approximately the average distance between the individual values of a data set and the center of the data set. So by the center of the data set, we mean the mean, the average, and standard deviation measures the approximate variation from each point of data from the mean. Let me give you an example. I want to go to the example or the formula. I'm going to go straight to the example before I show you the formula. I'm going to go ahead 2 slides. All right. Suppose we have 3 employees. Now I'm going to show you the formula. Sorry about that. It's fine. Okay. So, does everyone kind of understand what I mean by the average variation of each point of data from the mean of that data? Everyone kind of have an idea so far? All right, so how we're going to calculate that, say we're measuring trees in a forest. I'm going to calculate the average height of the tree at 12 feet tall. I want to know, on average, how different is each tree? Is each tree about 3 inches difference? Is each tree about 1 foot of difference? Do I have a lot of variation in this forest, or a little bit of variation in this forest? And how I'm going to calculate that is with this standard deviation formula. This funny looking O, we call this sigma. Also call this standard deviation. 2 steps. First step, I'm going to measure the mean. Remember this funny looking mu? That's the mean. All right? And then I'm going to take each point of data, each tree in this forest, and I'm going to measure the difference. So the tree in the forest minus the average. So this tree is 14 feet tall, the average is 12 feet tall. That's a difference of 2. Now the thing is, I don't care so much if it's a positive or negative difference. So I want just the absolute difference. This could be 9, and then the average would be 12, that would be -3, right? Alright, so it's either going to be a positive or negative number here. I don't care if it's positive or negative, so I'm going to square it. And I'm ultimately going to take the square root of that, but I'm going to start by squaring it to signify that I don't care if it's a positive or negative difference. So for each tree, I take the difference between that tree and the average. I square that. I divide by the total number of trees. And then if you remember, because I squared this at the beginning, I take the square root of that whole mess. And that's going to give me standard deviation. That make sense? All right.
Just for that one tree?
This big E, that's the sum of all those trees. So all the x's, and this xi, that means the first tree all the way up to however many trees I'm measuring. All right, so this is the whole population standard deviation. Suppose instead, I don't want to measure every single tree. I want to take a sample of 35 trees. Then I'm going to get a sample standard deviation. I would use little s to signify that I just took a sample. I would calculate it in a very similar fashion. Remember, when I take a sample, I get this x bar, sample mean. All right, I take the difference between each tree in my sample and the sample mean. I square it. I divide by little n, which is the sample size. I make a small adjustment. I subtract n by 1. By taking n minus 1 in the denominator, I make this whole number a little bit bigger. So a smaller number in the denominator makes the whole number just a little bit bigger, to account for the fact that I don't have all the trees measured in the forest, I just have a sample. So I make my standard deviation just a little bit bigger, and we'll find that that just makes us, allows us to make a less precise statement. Don't need to worry too much about that for right now, just imagine that being less precise. And then I take the square root of that whole junk and I get the sample standard deviation. All right, kind of make sense? Okay, I see some sort of nods. So now let me go to the example. All right, suppose you had 3 employees producing widgets. Over the course of one day, they were able to produce 3, 6, and 7 widgets respectively. So I have 3 employees. All right, you 3 are my employees. Danielle produces 3 widgets, Kristen produces 6 widgets, and Julissa produces 7 widgets. What is the population standard deviation of widgets produced? What's the first thing I need to do to calculate standard deviation?
Mean.
Mean, yes. All right. So 3 plus 6 plus 7 divided by 3 equals 5.3. I take the difference between the number Danielle produced and the mean, square it. The difference between the number Kristen produced and the mean, square it. The difference between the number Julissa produced and the mean, square it. Divide that whole thing by 3, take the square root of that. I come out with 1.7 widgets as my standard deviation. So the mean is 5.3. And 1.7 is about the average distance of each of their number of widgets from the mean. And that's about right, because 1.7, the difference between 1.7, or the difference between, let's see, the amount Julissa produced and 5.3 is pretty much 1.7. The difference between 5.3 and 7 is 1.7. The difference between the amount Danielle produced, 3 and 5.3, that's 2.3. So that's a little bit more than 1.7. But then the amount Kristen produced is only 0.7 difference from the mean. So it's about 1.7 difference is the standard deviation of the widgets they produce. All right, and does that make sense? All right, sorry if I'm trying to rush through here. I want to get through this. I want to try to go fast so I don't lose your focus. But if I go too fast, tell me I'm going too fast. Suppose instead that these 3 employees were just a sample out of 10,000 employees. And I want to calculate the sample standard deviation of these 3 employees. I do it in a very similar fashion, except I divide by n minus 1, which is 2. And because I divide by a smaller number, I get a slightly bigger standard deviation. I take a larger number to account for the fact that I didn't sample everyone. I make a less precise estimate. So my standard deviation, if this were just a sample, would be 2.08. Does that make sense? All right. So, that brings us back to our normal distribution. We know 2 things. We know the mean of this distribution, and we know the standard deviation of this distribution. I also know because this is normally distributed data, that the percentage of data within a given number of standard deviations is predictable. That is predictable because when I measure trees in my forest, and I plot those on a frequency distribution, and I calculate the standard deviation, and someone else in China measures trees in their forest, and they plot the distribution, they calculate the mean, they calculate the standard deviation, their curve looks exactly the same as my curve. And we call each other on the phone, and we're like, really? You have the exact same curve you time it? That's like crazy, isn't it? The reason that happens, it has to do with the coin flip example that we did. And I talked about the probability of a coin coming up heads one or two more times can be equated to the probability of a tree getting a little more sunlight, a little more water, and over large numbers. And as long as there's nothing going on in this forest that is skewing the data, like we looked at a couple examples of skewed data with those funny towns of rich people and poor people and all that, as long as it's just completely random, my forest is going to look exactly the same as the person in China's forest. And I'm going to know how many of my trees are going to be within 1 standard deviation, 2 standard deviations, 3 standard deviations of the mean. I'm going to know exactly how these curves break. My curve is going to break exactly the same way as the guy in China's curve is going to break. Law of large numbers, normal distribution is a natural phenomenon. 3 of the things we know. 1, approximately 68.38% of the values in the normal distribution will be within 1 standard deviation of the mean. So 68.3 of my trees will be within 1 standard deviation of my mean. Just like 68.3% of the guy in China's, his trees will be within 1 standard deviation of the mean he calculates. 95.5% of the values will be within 2 standard deviations of the mean. 99.7% of the values will be within 3 standard deviations of the mean. These are just a few of the things we know. I could tell you exactly what percentage of the data would be within 1.78%, or 1.78 standard deviations of the mean. Because I can calculate every single thing about how this curve breaks the same way you all started to calculate that binomial distribution with the coin flip example. All right. So, what does this mean? Well, the guy in China, his trees may have a different standard deviation than me, and he may have a different mean, a different average height than me. But we can put his trees and my trees on the same frequency distribution. We can say that we're going to standardize it. My trees and your trees, we're going to call whatever mean we get of 0, and we're going to call whatever standard deviation we get, we're going to call it 1. And if he does that with his trees, I do that with my trees, our bell curves are going to look exactly the same, and we can both talk to each other on the phone about the probability of one tree being 2.7 standard deviations above the mean. We'll be like, wow, what's the probability of that happening? And we'll both calculate it the same way. And when we put things on a normal distribution, we give them a z-score. And a z-score is just the number of standard deviations above or below the mean. So if the average tree size is 16 feet, and the standard deviation is 1 foot, and I have a tree that is 18 feet tall, okay, you with me? The mean is 16, the standard deviation is 1, I find a tree that's 18 feet tall. How many standard deviations is that tree above the mean? 16. Standard deviation equals 1. My particular tree equals 18. How many standard deviations is that particular tree above the mean? 2 standard deviations above the mean. That make sense, everyone? So we would take 18 minus 16 divided by 1 equals 2, divided by 1 equals 2. That's how many standard deviations that tree is above the mean. I would assign that tree a z-score of 2.
So. No, your M will, that will be an M, but
Oh, an M, sorry, alright, okay, so that's z-scores. Z-scores, alright. Alright, in my example, I had a tree size of 18, I had an average tree height of 16, I had a standard deviation of 1, I had a z-score of 2. Alright, it can be above or below the mean. Alright, now, I can do, suppose these are not whole numbers. Suppose I were to tell you I have a tree that has a z-score of 1.2. And I'm going to ask you, what is the probability of having a tree that tall? That has a z-score of 1.2. Well, what you're going to do is not only are you going to do that binomial calculation, but you're going to do every single number in between, all the decimal points, or someone else is going to do it for you, and they're going to put all that information in a z-table. And you'll have a z-table in the back of your book, and it will tell you the probability associated with any particular z-score. There's also a z-table in the back of your slides, and there's also a z-table, partial z-table, in the very next slide. So if I were to tell you what's the probability of having a z-score of 1.2, you would flip back to the z-table in the back of your book, and you would look how it works. Does anyone have, if you have your book with you, maybe you can open to the z-table. If you don't have your book with you, just look at on the back. Yeah, look there. That's fine. Look either one. Back or the slides. All right. How the z-table works is you will look down the vertical column for a z-score of 1.2. If it's 1.2, say if it's 1.27, then you would go 1.2 and you would go all the way across here to 0.7. So this is 1.27. What we're looking for right now is just 1.2. We will look for the area associated with that z-score. This is area under the curve. All right, and this tells us, this 0.8849, what this tells us is the area, the probability of having a z-score of 1.2 or less. .2 or less is 88.49%. We can tell that by looking at the z-table. Now, how did they come up with the z-table? They did something a lot more complicated than what you started to do with the binomial coin flip example, but not that much more complicated. You pretty much started to do the calculations that they did, except they just did a lot more of them. So does that make sense? Z-score of 1.2. What's the probability of having a tree that tall? Or you might say it a different way. You might say, what's the probability of randomly selecting any tree and have it being shorter than that particular tree?
88%.
88.5%. What's the probability of a randomly selected tree being taller than that particular tree? About 12%, 11.5%. Does that make sense? All right. Okay. Great. All right, I want to do this example. Maybe you'll recognize it from Turbo. It just can put this in context for us. Suppose we have some data on male height. Suppose we know that the average height for an American male is 70 inches and the standard deviation is 3.5 inches. And we are able to assume that the standard deviation is normal. Assume that the standard distribution is normal. Assume that the distribution is normal. I wrote that wrong. So we assume that the distribution is normal. Okay. Suppose further, we know that Michael Jordan's height is 78 inches. What is the z-score that represents Michael Jordan's height? Fire away. All right, how do we calculate this? Z-score for Michael Jordan. Anybody?
2.29.
That's, how much? 2.29? Yeah, that sounds right. Did you say 2.29? Yeah. All right, but what are the numbers we use? 78 is his height, minus the average of 70, divided by standard deviation 3.5, equals 2.29. Excellent. So Michael Jordan has a z-score of 2.29. All right, are we good there? Excellent. What is the probability that a randomly selected American male will be shorter than Michael Jordan? Keep in mind, we get to assume that this distribution is normal. Assume that it follows all those normal patterns. There's nothing skewing this data. What's the probability that randomly selected?
97%.
How much?
97.
Sounds. I like that one better. 99. How'd you get 97? You just guessed? Okay, so what we do is we look on the z table, and we look for a z-score of 2.29. And what do we see when we look under 2.29? 0.98? So, all right, so that's more exact, 0.98 what? How much? Oh, 0.989. So we'll say almost 0.99. So 99% of the data is less extreme than that. 99% of males have a z-score of less than 2.29. So the next male who walks by that door, the chances of that person being shorter than Michael Jordan, 99%. Chances of that male being taller than Michael Jordan, 1%. Excellent. Okay, suppose Isaiah Thomas has a height of 69 inches. What is the z-score for his height? Fire away. All right, what do we get for a z-score for Isaiah Thomas? All right, say it loud.
It's negative 0.29.
That sounds about right to me. You like that? Okay, so it's negative, which means Isaiah Thomas is shorter than the mean, and he's about 3/10 of one standard deviation below the mean. All right, so we have a z-score for Isaiah Thomas. Right? We're good. What is the probability that a randomly selected male will be shorter than Isaiah Thomas? Just give me the percent.
61.
All right, so I think that's wrong. The reason that's wrong is because you'll notice that the Z table on the back of your slides does not have negative numbers. So you will need to make an adjustment.
Subtracted from one.
Subtracted from 1. Yeah. So what it's giving you is positive 0.29 is giving you what? 60 what percent?
61.
Yeah, so 61%. So this part here is 61%. Alright? Thankfully, we know that the normal distribution is symmetrical, and it's identical on the positive and negative side. So what that means is, if this were positive 0.29, this would be 39%, right? And if it were negative 0.29, we could just flip those around. So probability of randomly selected male is shorter than Isaiah Thomas is 39%. 99%. Okay, we're good there? All right, I realize I'm throwing a lot of stuff here at the end of class, but there'll be plenty of time to absorb this. What is the probability a randomly selected American male will have a height in between Isaiah Thomas and Michael Jordan? How do we figure that out? Subtract the 2? Yeah? Alright, so let's make this clean here. Alright, so this is a frequency distribution for male height. It's normally distributed. We know that Michael Jordan, alright, the chances of, let's see, how do we do this? Alright, let's do it this way. We'll call this Michael Jordan. What's the probability of a male being taller than Michael Jordan?
1%.
1%, okay? This is 1%. All right, what's the probability of a randomly selected male being shorter than Isaiah Thomas?
39.
39%. All right, so we've got this part is 39%. This part is 1%. What's the part in the middle?
60.
Fantastic. Does this make sense? Okay, you should be very proud of yourself if you got that, because I threw a lot of that at you fast. We're going to do one more example. If you want to, you can always go home, I guess. But I recommend you do this last example so we can just kind of ingrain this. Suppose driving distance for work for residents of a certain community has a mean of 21 miles and a standard deviation of 3.6 miles. What is the probability that an individual drives between 19 and 26 miles to work? Assume that the distribution is normal. All right, so we've got a mean, 21. We've got a standard deviation, 3.6. We want to know the probability between 19 and 26. How are we going to attack this?
Just do every single one.
The same way.
Not every single one, but just 2, right? We need a z-score for this, a z-score for this, and we need some add, subtract, this junk here, right? So, does that make sense? Yeah? Okay, go. Let me make some room. do we get for the z-score for 19?
Negative 0.55.
0.55, I like it. And what do we get for the z-score for 26? 1.388. All right, so let's draw a normally distributed commuting distance to work. All right, and we need to know the area between 19 and 26. All right, so we know the mean here, the mean is 21. All right, use pink here for 19. All right, so this is 19. This is 21. And then in a minute, we're gonna need to find the z-score for 26. 26. Okay, so what is the probability of less than 19? Let's do it like that. We can do this in a number of different ways.
What's the third one? That's 25?
This is 19, 21, and 26. All right, let's do this. Let's do less than 19. What do we have there? So we look for a z-score of 0.55 on your z-table. 1 minus that is this area here. How much?
29.
29%? All right, this is 29%. Boom, 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 boom. All right. Now, how about the z-score associated with 26 miles? That's 1.388. And when we look up 1.388 on the z-table, what do we get? 93? All right, so I think it makes the most sense to calculate what we have over here in this part. So if we have 93 below 26, what do we have above 26? 7, okay. 7%. All right, and what's the question that we need to solve?
Between 19 and 26?
Yes.
So
All right.
29 plus 7 is 36, 36 minus 100.
Yeah, and what do we get, Danielle?
64%.
64% is the answer to our question? Is that right? Okay. You survived? You feeling kind of okay with that?
Can you go over the negative one more time, please?
The negative?
Yeah.
Okay, so we looked up 0.55, and what did we get when we saw that on the z-table?
So 71.
We saw 71. All right, so what that means, if we have a positive 71, or a positive 0.55, 71% of the data would be to the left of that. All right, and which would mean that 29% would be to the right. So if it's negative 0.55, we know it's just reversed. That 29% would be below it, 71% would be above it. So we know that this piece below 19 is 29%. And for the 1.3, we don't need to do that reverse because it's a positive 1.38. We look it up. Actually, we do. We do because we wanted to calculate the amount above. When we looked up at 1.3 on the z-table, it said 0.93 something something. And we knew that that meant there was 7% above, which left a total of 64% in the middle. So the answer to the question, what is the probability an individual drives between 19 and 26 miles to work? 64%. So if you were to walk up to someone in a party at that town and you were to say, hey, I bet you drive between 19 and 26 miles to get to work each day. What are the chances that you would be correct? 64%. All right, great. You should be proud of yourselves. You made it through a lot of material to get us started. For the quiz, I think there's a combination question, there's a binomial distribution question, set up the number of combinations, number of successes, probability of successes. There's a question, I think just like this. I forget what else there is. Nothing that would surprise you. Best way to prepare for it, go over the notes for tonight, do the homework exercises, work the Excel a little bit, see if that helps you with the calculations. You may want to use Excel for the quiz. You may be more comfortable using the calculator after you practice with it for a little bit. Question?
Oh, it's not for that.
No, from, okay. All right, I'll be here if anyone has any questions, otherwise I look forward to seeing you next week. Thank you. Good job, Kristen. I think you're getting a little tired, just stay focused.
You go from 1.3 on.
Okay.
So the quiz is at 6.
The quiz is before class
Yes.
next week.
Well, it's 1.38. So 1.38.
I know she's teaching.
Yeah, and
So I gotta go over the thing, because I missed your
Yeah. Yeah, 0.55 is gonna be about 71%.
I'm just
And
thinking
that
about
one's
the
right, so 29% on the other side.
No.
So you know that there's 71% lower than that,
So,
if it's positive. Which means if it's negative, then it's
because
1
this is like
minus.
very long.
That means that there's 29% lower. What's your name again? Kyle. Kyle. Or Kyle. Which is exactly.
A little concerned about how I didn't get a chance to.
Okay.
Last night.
Okay.
Okay, tomorrow, I mean, Wednesday when I come back, I'll try to go early.
Yeah. Just don't worry
Yeah, we'll
about
be here
it.
too.
The first week
Yeah,
is fine.
Wednesday I'm
Just,
doing,
I'm sure I'll be able to get it done.
yes,
We are.
and then Thursday I'm doing, yeah,
Okay.
so I kind of broke up.
Okay, I mean, don't feel rushed. I mean,
And then you
make
did
friends
business,
in class.
business,
Yeah, no, I was.
government.
The government,
If you need,
that
yeah,
shouldn't
like I
be
said, if it
that
doesn't come in
bad.
time.
I had signed up,
don't worry
that's
about it.
what I
I'll shoot
just,
it to you.
that's the
Okay,
one.
all right. Have a good night. Good night.
Oh, I missed the first part of the short.
Oh, sure.
So, I heard quiz, I get nervous.
Oh,
All right, so,
what's your name
this
again?
Maury.
Maury, got it.
We have a, I'm talking about like a real application. Granted, to make your phone
Here, all right, here. You're not on Blackboard yet? Okay, yeah, so go to mercy.edu, use your credentials to sign into Blackboard. Once you do, you will see.
I'll see you Wednesday.
You'll see a setup like this. You go to everything's under course material. You take the quiz. So first, all right, you have the textbook?
Not yet.
Okay. Okay, good. And I was just telling one of your classmates, if you do it at a time, you don't have to do the quiz before next week. I want to get it as soon as possible, so you don't get behind the class.
If you don't have.
Or you can make friends with someone in the class who's on the possibility.
That's what he says, right? You wanna get it over with.
Okay.
No, I wanna get it over, I can't, I gotta eat something, so it's again, understands again.
Yes.
It's
Cause,
gonna come by,
Wait, no, you said the quiz is
you know,
when did you say the
it's
quiz?
due by the 5th.
Due by the way, okay.
Okay, so once you get the book, if you look at chapter 2, you go to chapter 1, 2, chapter 4, exercise 1, you do all these exercises. These are recommended practice, I would definitely recommend all of them. Quiz. And then you'll do the Excel exercises, at the end of chapter 2, this one, and then chapter 5, this one, and then chapter 6, this one. For the Excel exercises.
oh, yeah,
Full Excel
very
exercise.
comfortable.
Yeah.
Click on that. You'll click on the first one. This one up. Alright, boom, and these are all the So this is chapter 2, exercise 1. Actually, I did this earlier for the rest of the students. You'll just fill in these parts. The textbook will explain exactly how you do it.
Okay.
For the mean, it's just need to use Excel, you know, Excel.
A little bit.
So equals average, open parentheses, select all these numbers,
That's how he's doing the calculation.
close parentheses, boom, alright, 35, and you'll just do all of those, and then you'll go on to number 2, and you'll do whatever else you do there, ready, same thing, chapter 5, binomial probabilities, all that. Okay, so that should reinforce it a little bit, the exercises will be very similar to the quizzes. Then, when you're feeling all good and confident, you'll go to course material, you'll go to class quizzes, you'll go to class quiz 1, open book, open note, we can do it individually, time limit 1 hour, 30 minutes, as soon as you start, you have to do all in one sitting. Click begin, there'll be 5 questions, like you went over class, like we did, put in the answers. No need to show your work, partial credit is not given, highlight your answers in bold. Okay, so that's it. What else do we have? Did you have a quick question by any chance?
We're just watching this.
Oh, good.
Yeah.
Following.
Yeah.
Following.
Good, good,
Yeah.
excellent, excellent.
If
All right.
there's a question.
Yeah. I know I'm gonna forget like.
So we know class quizzes, we already opened up the Excel exercise data, we filled in all those answers. Once we fill in all the answers and we save it, we're ready to submit, we go to class assignments. Click on that, click submit the first one. Now you know you need to submit the first one because you'll look on the syllabus and it'll say before December 5th
Right.
at 6:29 p.m. Take class 1 quiz and submit these Excel exercises. You'll upload something, I guess browse your computer, wherever you saved it on submit class 1 slides, whatever. Click submit, boom, you're done. Okay, what else do we have? I mentioned that a great technique to prepare for class is to look at the class slides. I will have these class slides up by Friday at the latest usually.
Okay.
I think this is easier than reading the chapter. So you can just look over the slides, know what we're going to talk about in class, it will direct you with certain things. Then you can read the chapter to kind of fill in, maybe attempt a couple homework exercises before class. I think it's just a better way to absorb the data. Okay, so that's class slides. And class video recordings.
Okay.
Yeah, and you can,
Listen back.
yeah, you can listen back. We're being recorded right now, actually. Okay, and one thing I forgot to mention, once you take the class quizzes, you can look at the correct answers. Like all the correct answers will
Oh,
pop up,
okay.
and then you can look back at the correct answers. You do that by going to My Grades. All your quizzes and assignments will be here. You'll click on the class 1 quiz. Then you'll click on either the score you got or this little bubble that says needs grading.
Okay.
And once you click on that, it'll give you all the answers. Do as quick. This is all the answers. Don't look, don't look, don't look, don't look.
Close my eyes.
Okay, oh, actually, it's on the video. You just go back, you scroll, you can slow it down.
Pause, right?
Oh, boy. Yeah.
How many questions are each quiz?
This first one is 5 plus 1 extra credit.
Okay, so for each quiz typically, the average amount of questions is like 5 for each quiz?
Yeah, yeah.
So if you get 2 wrong, that's bad.
I guess so. I have made an effort to make the quizzes more grade friendly. So I've taken out problem questions from last time, and I put an extra credit question in.
Okay.
So, yeah, so that's good.
I just took the con and and it's just, stuff I just need to review this stuff one more time. 'Cause it is kind of basic, but it's just, I just need to
Yeah.
review everything.
It's up to, yeah. And one thing, if you don't get the textbook in time, one thing you might do is just go over the class again, and just go over those examples we did in class.
Right,
Make sure
okay.
you're just rock solid on those.
I have to.
And your recording is exactly everything that we just did right now.
Yes,
So that's
yes.
gonna be available tomorrow or?
Yeah, tomorrow, next day, something like that.
Okay.
Yeah. How did it go towards the end of class? I tried to rush. Did that go okay?
Um,
Is that a little too fast, do you think?
It was okay.
I think it was okay, I mean, it's, you got the formula, you know, it's just applying the formula, and plus you got the video, people can go back, like, I'm gonna do that,
Yeah, definitely.
I'm gonna read, cause like, I can be honest with you, I'm a little bit fuzzy on some of the stuff here, but I know that I can go back on the video and I'll just review it,
Right.
and thank God I'm not taking 3 classes.
I
I'm just
sad I'm
taking
taking
2.
3 classes
That's-
now,
that's-
this is pretty intense, you know, and,
I gotta put my focus,
yeah.
yeah.
Good, alright, well, see you all next week.
See you next week.
Email me if you have any questions.
Good
Yeah,
night.
thank you.
Thank you.
Thank you.
Thank you.
I come way down the hill.